I think the problem is that just we simply have not done an adequate job of teaching our children. And so we've done that for generations. And so therefore adults say, I'm no good at math. And that's sort of okay. They think of it that way. It's sort of funny. And they communicate that to their kids, and people think it's only if you really have a math gene. But that's just so wrong. Other countries respect mathematics, and they expect all kids to learn it to some basic level. They're all not going to be math people, but they all can learn it to a basic level.
12, 13, 14, 15, 16.
That's very good. You're like...
I was a French major in college. In high school, I was fascinated with languages and humanities and social sciences, and found my way toward elementary school teaching where, in fact, of course, math was one of the subjects I had to teach. Within a few years, I found that my ability to teach my own students math was less good than my ability to teach other subjects.
You're doing fine.
I can't even find.
You can't think of other ones?
What? Oh my God.
So I began studying math at that point once I was an elementary school teacher. And that essentially grew and launched an interest that I've had ever since in the question about what is it about teaching young children mathematics what is it that it demands of the teacher?
Squares out yet. I want to give you some directions for how to work on this. You're going to work in teams today. And on your team,
an elementary math lab is first and foremost a program for school children in the area, and we deliberately designed this program to enroll students who are struggling in mathematics. And we chose the age level of entering fifth graders, who are about 10, because this is a key age at which children who begin to find math difficult or struggle with it really fall behind. It's first and foremost a laboratory in learning and in teaching.
I want you to write down the way you'd record it with multiplication, and I also want you to write down or sketch the rectangle.
Another feature is that we gather really good records of the work across the time of the laboratory class. It runs for 2 weeks, every day for 2.5 hours, and during that period we videotape with more than one camera everything that's going on in the classroom. So as a product of the laboratory, we have very high quality digital records that could be used for research purposes, for viewing by groups who aren't there live, to create materials that could be used in teacher education elsewhere or in professional development.
One wonderful thing about the National Science Foundation is that we've been funding work in mathematics education aimed at improving mathematics teaching and learning for more than 50 years, going back all the way to the post-Sputnik new math curriculum and studies that were done in those years. So we really do have a wonderful cadre of experts who've been studying mathematics teaching and learning, who've been studying international questions about mathematics education, who've been developing and testing curricula, and who've been working with teachers to improve the preparation and continuing growth of teachers. I'd like to make a pitch for the importance of research about mathematics teaching and learning, because everybody took math. It's possible to think that everybody does, in fact, have strong opinions about how math ought to be taught and how math ought to be best learned and so forth, and that needs to be supplemented and examined more fully, I think, through systematic research that can look at questions of teaching and learning, that can look at the ways in which certain materials might impact certain learners and so on. So I'm very much supportive of the idea that interdisciplinary research that brings together mathematicians, scientists, mathematics educators, psychologists, cognitive scientists, statisticians, teachers, that's going to be part of the key to being able to solve some of our mathematics learning problems. Current reports and documentation would suggest that we are at risk relative to competitiveness and innovation, that we want to be sure we have a well-prepared scientific and technological workforce, and mathematics, of course, is at the center of that. But I would also add to this that it's important to have a mathematically literate populace and citizenry, people who can make sound decisions in their daily personal lives, who can read and understand issues about health that depend upon statistics and mathematical ideas. So again, both in terms of our technological and scientific competitiveness as well as our everyday life, I think math is important.